Hi everyone, welcome to lesson 2.5. We're still working on sketching quadratic functions and we're building on the parent function and then all the transformations that lead up to graphing more advanced functions. So previously we started with y equals a times x squared, and we saw how this coefficient of a will change a graph. It can flip a graph upside down. It can stretch a parabola vertically. It can compress a parabola vertically. So we'd see in the characteristics that A can show up when they graph the parabolas. Next, we took a look at adding this C value to a function. And we recognized that C moved the parabola up and down. If it's positive, it's shifted up. And if it's negative, it's shifted down. In these forms, the vertex was easy to identify, and it happened at 0 and whatever the C value is. The axis of symmetry here was also x equals 0. Axis of symmetry. But we eventually want to build up to that standard form. So standard form is equal to y equals ax squared plus a bx plus c. So we're now introducing this middle term into our quadratic. And so now when we do that, determining the vertex and other characteristics are not as easy. So let's take a look. Here what I did was I graphed y equals 2x squared minus 8x in green. Sorry, in blue. Then y equals 2x squared minus 8x plus 6. So shifted it up. So what is the x coordinate of each vertex? And it's hard to see the graph. But this value right here, this is a 2. Once I have labeled that and I have the vertices labeled, then the x coordinate of each of the vertex is 2. Now, if I go up to the 2x squared minus 8x, which is the blue one, I'm asked to find the x-intercepts. And the x-intercepts are where the parabola crosses the x-axis. And that is here and here. And if I look closely, it looks like it is 0. And this one looks like it is 4. So I'm going to go back and write that in. The x-intercepts are 0 and 4. Can you see a relationship between these x-intercepts and the x-coordinate of the vertex? So in fact, the number 2, or the x-coordinate of the vertex, falls right in between 0 and 4. It falls right in between the middle between the two x-intercepts. So going forward then, algebraically, we can find the x-coordinate of the vertex. We can find the x-coordinate of the vertex and the axis of symmetry by this little equation here. So negative b divided by 2a. And a, again, is the coefficient of the x squared term. And now we're adding that middle coefficient of bx. So b is the value of the x term. C, as it turns out from the last lesson, also coincides with the y-intercept. So let's walk through and read through this example. Find the axis of symmetry and the vertex of the graph y equals 2x squared plus 8x minus 1. So in this function, we can identify that the a equals 2 and the b equals 8. So again, this helps me find the x coordinate of the vertex. So if I substitute 2 and 8 in for a and b, I'm right here. X equals -8 divided by 2 times 2. Simplifying, we get x equals -2. So this gives us two things. It gives us the x coordinate of the vertex, but it also gives us the axis of symmetry for the function. So to find the y-coordinate of the vertex, we can just take this value and sub it into the original function, just like we did here. So we see it subbed in here and here. Remember the original function, y equals 2x squared plus 8x. When we simplify, we get y equals -9. So let's fill in here. The axis of symmetry is x equals -2. And the vertex we found is -2, -9. The y-intercept, as stated above, is the c value. So here, the y-intercept is -1. So we haven't quite talked about domain and range, so we're going to do that here. So the domain of a function is the set of all the possible x values that you can plug into a function. When we're talking about a quadratic function and we're talking about parabolas, there is no limit on what x values you can put into the function. Now the range refers to all the y values and all the possible y values that can come out after you plug in the x values. So for notation, for quadratic functions, the domain is all real numbers. That means x is an element of real numbers. No restriction there, okay? So you can see these different notations, but they mean the same. The domain is all real numbers. For quadratic functions, the range depends on the vertex and whether the parabola opens up or opens down. So for a's that are less than 0, the range is greater than or equal to the y-coordinate of the vertex. For a's greater than 0, the range is less than or equal to the coordinates of the vertex. Because if a is less than 0, we know the parabola opens down, and if a is greater than 0, we know the parabola opens up. All right, which leads us then to the maximum and minimum. So the range helps us determine the maximum and minimum of a function. Those are the highest maximum or the lowest minimum value that the y-coordinate of the vertex has. So if a, again, is greater than 0, the parabola opens up and the vertex would be considered a minimum. And if a is less than 0, the parabola opens down and the vertex would be considered a maximum. So if we take a look at the graph, the vertex here is 0, 0, but it opens down. So the y value of the vertex, which is 0, is considered to be a maximum. So you can see that this parabola is never coming up over the horizontal line here. So let's take a look at some examples. Find the axis of symmetry, the vertex, state whether the vertex is a maximum or minimum, and state the domain and range. So here we go. Let's find the axis of symmetry by using our equation. X is equal to negative b over 2 times a. So here, negative 4 divided by 2 times 1. This gives me an x value of 2. So that's my axis of symmetry. Now, to find the y value for my vertex, I have to plug this x equals 2 into the function that I'm looking at. So y equals 2 squared minus 4 times 2 plus 3. I simplify this. This is 4 minus 8 plus 3. And it looks like y equals negative 1. So now we know the vertex is 2, negative 1. And so the domain is x as an element of all real numbers. And the a here is a positive 1. And with a positive a value, we know that the parabola is going to open up. And so the range has to be a minimum. So the y values have to be greater than or equal to negative 1. Our next example. Let's start by finding the axis of symmetry. X equals negative 8 divided by 2 times negative 1. The axis of symmetry simplifies to negative 4. Now we'll plug that x value into the function and we'll find the y value for the vertex. So y equals negative 4 squared plus 8 times negative 4 plus 6. Be careful here with these negatives. This is going to be y equals negative 4 squared is 16 minus 32 plus 6. And if I simplify, y is negative 10. So my vertex here is negative 4, negative 10. My domain, always the same, x is an element of real numbers. And here, we look in front of the x squared term, we have a negative a value, which means this parabola is going to open down. So the range then, y values have to be less than or equal to the y value of the intercept, which is negative 10. We'll do that one more time. So here we have y equals 2x squared plus 8x minus 6. And we'll find our axis of symmetry. X equals negative 8 divided by 2 times 2. X equals negative 8 divided by 4, negative 2. So that's my axis of symmetry. To find the y coordinate, we're going to plug in negative 2 into the function. So y equals 2 times negative 2 squared plus 8 times negative 2 minus 6. If I simplify, I get 2 times 4 minus 16 minus 6, and I get y equals 8 minus 16 minus 6, and my y value is -8, -14. So my vertex is -2, -14. My domain is x, all real numbers. Because my a value in this function is positive, my graph opens up. The range is going to be y greater than or equal to the y coordinate of the vertex, which in this case is -14. So here we're going to take a look at graphing, but this time we don't want to use a table of values. With a function in standard form like this, using a table of values would take such a long time. So now we have different tools that we can use in order to graph the function just based on certain characteristics. So we do have standard form. And in standard form, we have an a that equals 1. We have a b that equals -6, and we have a c that equals 10. So in standard form, let's start with finding our axis of symmetry. So x equals -6 divided by 2 times 1. So x here is -6 is positive, +6 divided by 2. The x axis of symmetry is x equals 3. We're going to plug that in to the function. So y is going to be equal to 3 squared minus 6 times 3 plus 10. So y equals 9 minus 18 plus 10, and we get a y equal to 1. So we have a vertex of 3, 1. So in order to graph this, we have a few points. We want to get maybe one more point. So let's just choose something between 0, 0, and 3. Because if we take a look at what we have the vertex here. Sorry, the vertex is at 3, 1. So on a graph 3, 1, here's my vertex. And we have our axis of symmetry that runs through the middle of the vertex. And that is x equals 3. And so we need to find a couple of things on either side to complete our graph. So with an a equals 1, we know that our step pattern should be 1, 3, 5. In standard form, with the c equals 10, we know that we have a y-intercept that equals 10. So let's go to our graph. I'll zoom in here a little bit. Maybe we'll use the step function. All right, so the step pattern. So our step pattern should be 1, 3, 5. So if I go over 1, I should go up 1. And I'll put a point there. And if I go over 1, I should go up 3. I'll put a point there. And over 1, I should go up 5. 1, 2, 3, 4, 5. So I use my step pattern to find those. That is 1, 3, 5. And I can use my symmetry to find the other ones. So a mirror image of 4, 1 should be at 2, 1. And a mirror image of 5, 5 should be at 1, 5. And then we knew that the y-intercept was 10 because that was the C value. So it looks like it lines up nicely. And we'll draw in the curve on the right and on the left. So it may have taken us a little less time, I think, instead of doing a table of values for a long function in standard form, like what we were given. All right, let's do another one so we can practice this. Again, a complex function in standard form. I don't want to use a table of values. So let's start by finding the axis of symmetry here. So x is equal to negative, our b value is 2, divided by 2 times a, which is 1/2. So x here equals -2 when you simplify. Let's find the y value of the vertex. So y is equal to 1/2 -2 squared plus 2 times -2 minus 2. So this is y equals 1/2 times 4 minus 4 minus 2. Y equals 2 minus 6. Y equals -4. So this means that the vertex is at -2, -4. And our axis of symmetry is x equals -2. So let's go ahead and start with that. We'll plot our vertex at -2, -4. We'll start there. And we'll plot our axis of symmetry, which goes straight through our vertex. And that is at x equals -2. And if we take a look at a here, because the a is 1/2, our step pattern should go from 1, 3, 5, which is the parent function. A is 1/2, so the step pattern for this function should be 1/2, 3/2, and 5/2. In other words, 0.5, 1.5, and 2.5. So let's see if we can follow the step pattern here. We'll zoom in pretty close. So the step pattern is over 1, up 1/2. Over 1, up 1.5. And over 1, up 2.5. I'll plot my points there now. So there, there, and there. So zooming in, let's say this step is 1/2. This step is 1.5. And then this step is 2.5. So here we go with the right side of the parabola. And then using the axis of symmetry, let's go ahead and plot the point on the other side. So there you go. Here and here. And that's how we'll get the left side because of the symmetry. All right, we had a different example here. I'm going to let you work through that one. Again, standard form. Your A is a -1, your B is 4, and your C is -4. So go ahead and see if you can find the axis of symmetry, the vertex, and the step pattern. That'll help you graph that. And then here with some of our last examples, we just want to be able to tell whether these functions have a maximum or a minimum. So here, A is 3. That's positive. That means the function opens up, and so we have a minimum. In order to solve for the value of the minimum, that means we're looking for the y value of the vertex. So we need to start by finding the x value, which is going to be -18. That's the b, divided by 2 times a, which is 3. X is equal to 18 divided by 6. X equals 3. So that is the x value of my vertex. And to find the y, we're going to plug that x value into the function. So y equals 3 times 3 squared minus 18 times 3 plus 15. And simplifying that, you get 3 times 9 minus 54 plus 15. And if we simplify that using a calculator, we get y equals -10. So what does this value represent? This is the minimum of this function. The minimum of the function is -10, which means the range is going to be y greater than or equal to -10. A couple more times. A here for letter B is -5. Negative, which means it opens down. So we're talking about a maximum. Let's find the x coordinate of the vertex by x equals -10 all over 2 times -5. Simplifying this one's easy. We get x equals 1. And we're going to plug that into the function to find the y value of the vertex. That's going to be it's going to be -5 times 1 squared plus 10 times 1 plus 7. Y is equal to 5 plus 10 plus 7. Sorry, this is -5. And y ends up being 12. So what this means, because we have a maximum, the range is going to be all y values less than or equal to 12. And one last time. A here is equal to -4. That means we have a parabola that's going to open down. That means we have a maximum. Let's find that maximum, and we have to start with finding the x value of the vertex. So x is equal to -4 divided by 2 times -4. X is equal to -4 over -8. X is equal to 1/2. Let's plug this into y. The function y equals -4 times 1/2 squared plus 4 times 1/2 minus 2. Y equals -4 times 1/4 plus 2 minus 2. And y here equals -1. So because it's a maximum, our range in this situation is going to be y less than or equal to -1. And there you go. So a lot to that lesson. Go ahead and take a look at the worksheet and let me know if you have any questions.